Hi, and thank you. As Martin said, I'm Michał, I'm from Red Hat, and I'm here to show you Quarkus again. There were quite a few Quarkus sessions here already, so I hope that for those of you who were there, this session could be some kind of a wrap-up. I was supposed to be doing this session with Martin Kouba, one of the core engineers of Quarkus, and we worked on the presentation together, but he unfortunately couldn't make it, that's why I'm alone. Okay, so let's get to it. Quarkus. Quarkus is a new project, as I said, from Red Hat, and is an application generator or a full-stack framework. You may think of it like as something like Thorntail or Spring Boot, or maybe even an alternative to a fully-blown app server like Whitefly. As everything from Red Hat, it's 100% open source, but it's still in beta. You may wonder what's the motivation to create such a project, and the motivation is the cloud. Java is an awesome language. It sometimes requires a bit too much of a boilerplate, but it's easy to read, easy to write, easy to debug, has great IDE support, and lots of awesome libraries. But it runs on top of a JVM, and JVM has some weight itself. Moreover, lots of Java frameworks do initialization and startup. This sums up to high memory consumption of Java applications, and also usually long startup times. While that's okay in on-premises solutions, it's not so much in the cloud. In the cloud, memory is quite expensive, and also cloud lets you scale out your applications easily, but if your application starts slow, you cannot take full advantage of that. So Quarkus tries to address these shortcomings, and it does it with GraalVM. GraalVM is a new Java VM from Oracle, and has lots of interesting features, but the ones that are interesting in the Quarkus perspective are substrate VM and native image. They allow for efficient, ahead-of-time compilation of Java applications to native binaries. So how much we can gain with that? It's quite a lot. So here are some memory measurements for Quarkus applications. And there are two important things about these graphs. First, this is total memory used by applications, so not only heap, but everything the JVM adds, like code cache, etc. So a Quarkus application that's just, and the second thing is that what's measured here is not only values after startup, but values after startup and handling first request to make sure that any lazy initialization doesn't hide anything from us. So the measurements were made for a simple REST application, and the Quarkus application that just exposed REST was able to fit into 74 megabytes of memory. That's quite good for a JVM, and this is on JVM. But so probably better than most of the other frameworks. But if you compile this application to a native binary, you will be able to fit it into 13 megabytes of memory. So quite impressive in my opinion. If you add to your application, it will obviously grow. So if you add some database stuff to it, it will fit like 130 megs. But if you compile it to native, it will also shrink quite noticeably to 35 megs of RAM. So this looks quite nice in my opinion, but this thing looks awesome. This is startup time plus first response time for Quarkus applications, and as you can see, Quarkus application running on JVM is able to start and handle a request in less than a second. But if you compile a Quarkus application to a native binary and run it, it will be able to start and handle the first request in not much more than 10 milliseconds. And if you add database stuff to it, it will be still in a couple tens of milliseconds. This makes applications written in Quarkus applicable for serverless, and we are talking like user-facing serverless, because user won't even notice that the server was down when his request hit the system, and because startup time is so fast. So this is what we gain with Quarkus. Now let's dive in a bit into how you can use Quarkus. So thankfully, you don't have to learn anything new, basically. So you can expose your RESTful APIs with JAX-RS. If you're not familiar with JAX-RS but are with Spring stuff, it maps really easily. You can inject dependencies with CDI, but you can also use Spring annotations for dependency injection. They will just be translated to CDI annotations on the build time. And you can talk to your database with Hibernate or JPA. And here, Quarkus comes with an add-on called Panache that simplifies things, and I will show a bit of it on the demo. But the old frameworks are not everything that you can use with Quarkus. You can also use Eclipse MicroProfile. MicroProfile is a set of specifications that address cloud-native stuff, help you write cloud-native applications. I won't go through all the specs, I just highlight a few of them. So one of them is MicroProfile fault tolerance, and this is for defining things like circuit breakers, bulkheads, timeouts on your code, and you can do it with annotations. MicroProfile also contains MicroProfile JWT, that stands for JSON Web Token, and this is a specification thanks to which you can secure applications with the set JSON Web Token. This is generally a token that contains, for example, user roles, and is signed by the token issuer, some trusted authority, and then a service, when it gets such a request, can verify the token signature without the round trip to the issuer, and process the request accordingly, and you can use the common annotations like roles allowed to define security. MicroProfile also comes with a couple of specifications targeting monitoring. One of them is MicroProfile open tracing. If you add it to your app, it will start sending spans of time a request spent in a service with some meta information to a server like Jaeger or Zipkin. And then when you open Jaeger UI, you will be able to view the path a request went through your system, see the bottlenecks, etc. Another one that is in the family of monitoring is MicroProfile metrics. This one in turn exposes some metrics of your application, like garbage collector stats, memory usage, etc., thread count. And it does it in JSON format or Prometheus format, so we can hook it into Prometheus. And you can also define some application-specific metrics easily with MicroProfile metrics. There's also MicroProfile health that exposes endpoints that say if the application is okay. This is especially useful if you use Kubernetes, because you can point Kubernetes liveness and readiness probe to such health checks. And then Kubernetes will know when your application is ready to handle traffic or when its spot should be wiped out and recreated. There is also a set of specifications for reactive programming, like, for example, reactive messaging or reactive stream operators. They allow you to, for example, talk with Kafka or AMQP. And there's also MicroProfile context propagation that does context propagation, and context is, for example, Hibernate session, and it propagates the context to an async invocation. And it's all written on top of Vert.x, so it performs well. So this was some overview of the capabilities, but Quarkus is not only about using some nice API and providing good numbers. It's also a huge step forward in productivity. The biggest thing in this area is the development mode. With it, you get instant reload. So you have to run your application with some special Maven or Gradle plugin. And then when you modify your code or configuration, your application will be reloaded on the fly. And the scope of the applied changes is really wide, so it even it even contains DB schema changes. Also in the development mode, application automatically listens on port 5005 for debugger. Not a big thing, but useful. Another important factor is the configuration. So as basically all the modern frameworks, Quarkus doesn't need configuration if you do just standard stuff. So if you just have a REST service that you expose on port 8080, it will just do that without any configuration. If you want to change the port or if you want to talk to a database, you need some configuration. But if you do need some configuration, you have one config file for it. It's like in a uniform format, and it's compatible with MicroProfile config, and that means that you can override your config properties with system properties or with environment variables. Again, overriding with environment variables is nice in the Kubernetes world when you can have a config map and inject environment for a pod from the config map. And MicroProfile config also means that you can provide your config sources in an easy way as well. Quarkus also comes with some helpers for testing. So there are JUnit extensions for JUnit 4 and 5, and also some capabilities to run the tests against the native binary. As I wrote here on the slide, you can use the same test code for both native and JVM tests. But what's important to keep in mind is that the native tests are not executed in the application, so you cannot inject any CDI beans into your test, and it's like client-side tests. So you can use, for example, rest assured to test your endpoint. Let's take a look a bit deeper in how it works. So as I already said at the beginning, for the native execution, it uses substrate VM. One of the powers of substrate VM comes from dead code elimination. So during the compilation, substrate VM analyzes the whole graph of your application and libraries it uses and eliminates everything you don't need. And I heard the lead of Hibernate saying that, for example, for Hibernate, if you don't use Oracle, and then you don't need like a couple hundred classes from Hibernate library, and they can be removed during compilation. So this is the gain. The gain in the biggest part in the gain if it comes to the memory usage. But it comes with limitations. So, for example, reflection needs registration. Dynamic proxies need registration. Dynamic class loading and such stuff is not even supported. Some things work a bit differently. So this may not be the things that you work with directly every day, but these are the things that almost every library you use uses under the hood. So Quarkus tries to replaces the class path scanning that is usually done in the runtime with build time stuff. Actually, it tries to do almost everything that is done in the runtime in the build time. Provides some means for registering classes for reflection, resources, etc. And tries to adjust that code elimination for the frameworks to work. So you can not only think of Quarkus as a full stack framework, but it's also an API for creating extensions that allow frameworks to work in the native mode. This is a bigger picture of how it works. So you have Quarkus extensions, like for example RestEasy or Hibernate, that use Quarkus core to handle all the stuff like reload and native stuff. Quarkus core in turn uses Jandex for classes, scanning classes, annotations, etc. Uses Gizmo for bytecode manipulation, and uses Graal SDK. There's also Arc, that is a almost CDI implementation that works well in this environment. and you can use Quarkus applications on hotspots, meaning on normal JVM, or on substitute VM in the native mode. Now I'd like to show you some demo. So for the demo, I chose a system that consists of 3 services, and I'd like to live code one of them with you. The system comprises of search engine, which takes a query and consults a database that has mappings from keywords to some search results, and also forwards queries to a Kafka topic. And there's also ad service that consumes user queries from the topic and prepares some personalized ads based on that. And there's a front app that just has a page and forwards queries to both of them. Here is a bit.ly link if you're interested in the code. So let's start. I have some cheat sheet here, but I'll start without it. So if you want to start working with Quarkus, the easiest way to start a Quarkus project is to generate one. Quarkus comes with a Maven plugin, and this Maven plugin has a create goal. So you can just run it. You can provide all these group ID, artifact ID that it will ask me for in system properties. So let's call search. I want to rest resource and call it search endpoint, for example. Let it be on path search. Let me open it in IntelliJ, and I will show you the front end of this application in the meantime. So open, demo, and search. Okay, so it's opening, and through. This is how the search engine looks like. Oh, sorry, oh. Can you see the letters? Okay, so this is how it looks like. There is this personalized ad on the right side, and a place to enter a search term and a search button. So I can search for Java, for example. The search engine is not there yet, so it will return some fallback stuff. So there's a fallback and my Twitter address. Okay. So let me first start this application. So we'll see what we have here currently. Compile. And let me go through the code as well. Oh, sorry. I have to change something. So what I have generated with Quarkus plugin is a POM file, so Maven configuration file that basically has Quarkus BOM. This is a file that describes all the Quarkus extensions with versions, but also all the dependencies with versions. And then I have one meaningful dependency, runtime dependency, that's Quarkus RestEasy, and then there are 2 dependencies for testing. And this generated POM also contains Quarkus Maven plugin definition for building the application, some Surefire configuration, blah, 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 and also a profile for native compilation. So this is configuration. It also has application properties that are currently empty because I don't need any configuration if I don't do anything that is non-default. The search endpoint that it asked me about, and also 2 Docker files, one for generating a Docker image for the native binary and one for generating a Docker image for the JVM version. So yeah, it failed. It failed because I'm using port 8080 here, and I'm using port 8080 for the front service. So I need to change it. To change it, I'll just modify the configuration to specify a port to 8180, for example. And this is one of the rare occasions that you have to restart Quarkus. Okay, it started. Let me shrink this window a bit and show you console here. So it started. It has this search endpoint. On path search should return hello, so let's curl it. Oh, it's not 8080, 8180. Okay, hello. So the way the front service works, it sends user query and user ID in query parameters. So let me add some query parameters for that. User ID, string user ID, and query query string query. Okay, and just to see if it works, I will return this instead of hello. So be user ID query, and let me curl it. And it returned null because I didn't provide user ID and query, so that's expected. Let's send user ID and query. And query, let it be awesome job. Okay, it works. I will need to split this query into keywords so that I can map it to the pages, to the addresses I want to return. So let me do it now. So I want to have list of string as keywords. And I will just split the query. And so query, oops, split on anything that doesn't fit to the word, to a word. So not a word character. Okay, and then let's return keywords instead. Okay, awesome Java, great. Now what I'd like to return from here is JSON, obviously, and not some text plain. So I need to add another extension. So let me, maybe I'll just start it here and not there. So let me first find an extension that will fit my needs. So what I do if I want to find a Quarkus extension, I'm listing extensions, available extensions. And Quarkus Maven plugin comes with that. So here's a list of Quarkus extensions. And the one I'm interested in is Quarkus RestEasy JSON-B. This provides JSON support for RestEasy, so for the JAX REST implementation that is used here. So I will just add the extension. And to do this, I can do mvn Quarkus add extension, and then specify the extension. Okay, add it. Let me shrink that back again. And now I would like to start the application again. Compile, or maybe clean compile, Quarkus, dev. Okay, so instead of text plain here, I want an application JSON. Let's say that consumes it as well, just to be consistent. So user ID, query, and I can return a list now here. So list like that, and now a list here. Let's see if it works. Yep, it worked. So now I finally reached the place the moment when I want to talk to a database. So I need again some extensions for that. This time I won't bore you with showing the list of extensions again. I'll just try to type it from my head. So it will be Panache, this Hibernate on steroids, and also I would need something for Postgres that I'm running locally, so let it be JDBC Postgres. Obviously I'm not using whole names of extensions because they're quite long, but fortunately the plugin is able to figure out the extensions by substrings. So I should have database capabilities already. Let me start it, start a server. Please note that I didn't add any entity or configuration for the database before starting it. I will be adding it and not restarting application. It will restart itself in the background. So in this situation, I unfortunately need some configuration again. And this configuration I have prepared for you so that I don't make mistakes. So I have to define a data source URL, a driver, username, and password. So nothing you wouldn't expect. And I also used a DB host property and used it in the URL property. I think that's a nice feature that you can do that. So we should have access to the database right now. Let me create an entity. Oh, there's one more thing that I added here and didn't tell you. So I also added a Hibernate database generation strategy, create the drop. So now on every restart, the database will be recreated. I added that just to be able to modify the entities as I want, and Hibernate will create the tables for me. So let me add the entity that will contain the mapping from keywords to pages. That's called page keyword. Not the best of names, probably. And let's extend a Panache entity. Thanks to that, I won't have to bother with generating ID for this entity, and I will get for free some methods for listing entities, persisting entities, etc. So let me define a field for page and a field for keyword. We can try to check if the application still works. Yes, it does. So let me now map these keywords to some pages. So let's do page keyword. And I can find the keywords this way. I don't have to inject any entity manager. Panache gives the static methods on an entity. So I will find, and I don't have to write full JBQL here. I can write something like keyword in my list of keywords. Now, let's call DB query. Let's do something like this, and it's not a type of Panache entity base, but it's a page keyword. And what I can do with DB query, I can, for example, list all now or get paginated results, but I want to stream it. So let's stream it. And I'm interested in pages from page keyword entities, so let me do page keyword page. I want distinct, don't want duplicates, and I want to collect results to list. So let me try it. Okay, it worked. It returned an empty list because I don't have the mapping in the database yet. So I'd have to add some inserts, but then the database is wiped out on every restart. So for the development, Quarkus comes with a nice feature that you can have a file called import SQL in resources. And this import SQL will be applied on your database on each restart. So I have prepared some inserts there. I added into it to import SQL. And let me curl with some JSON stuff so that you can see the results better. So yeah, and I got results. Please note that I didn't do any restarts since adding the extensions for talking with Hibernate. So talking with the database. Okay, so we have some results here. I think it's time we can take a look at our UI if it started working with the service. So let's query for Java. Oh, it worked. Okay, but the ad is still the default ad. And that's why, because we are still not feeding the Kafka topic that the ad service is listening to. So let me add that. Again, I need some extension for that. I'm lazy, so I will just type Kafka in hope there's only one extension for Kafka. I think there will be two, but no, there's one. Reactive messaging Kafka. So let me start it once again. Okay, it started. Now I still, again, need some configuration. Yep. So, for talking with Kafka, I'm using MicroProfile reactive messaging. That's why I have this strange key here, like that says MP messaging. And I will be writing to this Kafka topic, so it's a definition of an outgoing thing. And I called it search terms. I don't know why. So I have to define a connector, topic, bootstrap server URLs, and a serializer for values. Okay. So now I'd like to write to this thing. What I will be using is an emitter that also comes from, this one comes from small reactive messaging. This is our implementation of a MicroProfile. So it will be an emitter of JSON object, and that is Vert.x JSON objects. And let's call it query emitter, for example. And what I need to do is to add a stream annotation on top of that, and say that the stream I'm interested in is search terms. And now, with a thing like that, I can just start writing to the topic. So query emitter, send, and I will create a JSON object that will contain the data. So new JSON object, put user ID, and put query. Okay, should be okay. There's one thing that may fail because I'm splitting the query and query may not come. So let me just do a check on that. Query equals null, or even if user ID equals null, then I just want to return an empty list and just don't bother with the request. Okay. So let me try it. I have a Kafka consumer here. Let me curl it and see if it hits my topic. Oh, yes, it did. So now, when I go to the page, I should be able to get some personalized ads. So let me ask for awesome stuff. It returned Quarkus and also advertised Billie Eilish. And if I do Java here, it will start showing some random advertisements because there are more for Java. Hopefully. Come on, yes. Okay, so this is the functional part of what I wanted to show you. I still have some time, a lot of time, so I will show you more MicroProfile. Okay, I think I'd like to show you MicroProfile open tracing. So let me do it. MVN Quarkus add extension. I will add open tracing, open API maybe as well, metrics to my application. Oops, no, the wrong directory, sorry. Oh, I killed my Kafka consumer. This one. So, where was it? Should be there. Let's start it, and let's see what happens. So I have Jaeger working here already. I will need Chrome for that because it knows my Jaeger URL. Okay, so this is Jaeger. I already have ads and front reporting to Jaeger. Let me just hit front once again so that the request comes from it to the set service, and we can get a span that will show the communication. So Java or maybe native this time. So native returns Quarkus and Micronaut. Oops. Why did I miss it? Oh, here it is. Let me find all the traces from front. So you can see there are lots of requests for ads because the ad widget, let's call it, periodically checks for a random ad. So let me choose an operation for the search operation that I'm interested in. Oops. How come? It didn't work. Oh, it didn't work because I didn't configure it. So let me quickly fix it. Obviously, I need to somehow point to Jaeger to make it work. So I should have it working now. Let me make a request again. So let's make native and let's make awesome. And maybe also Java. And let's go to the back to the Jaeger UI. Find traces. Nope, still not here. Is Quarkus here? Maybe I didn't save the file before restarting. Okay, let's search for Java once again and for awesome once again. Yes, it should be here now. So operation search, find the traces, and here it is. So as you can see, there was a request for front local service, and it in turn called search local. Search local took 3 milliseconds to process it, nearly 3, and front local took like 7 in total. So this is open tracing, and as you saw, I just added some configuration and open tracing extension. I also added Open API. Oops, sorry. So let me show it this way. So I can curl for Open API documentation as well. It will be auto-generated just because I added the extension. Here it is. I have, oh, it's 8080. So let's do 8180. So there's one endpoint, get, has 2 query parameters, user ID and query, and that's all. And there's also metrics, call JSON. Okay, these are the metrics. So as you see, some garbage collector stuff, available processors, Jaeger stuff is added here as well, memory, thread count, etc. All for free. You only need to add extension, and you can add some metrics of yourself to your application. And I'd like to take this application and deploy it to my locally running Minikube. And I will use the Docker images.com generated with a generated application. Oops, I didn't want to do it, sorry. So let me use Docker build SFC Docker file and let it be search v98, for example. So, before I do it, I need to do something for my Docker to know to upload an image to my Minikube. So Minikube comes with something like that. It is able to create Docker environment that will instruct Docker to upload images to Minikube. Oops. Docker build -f. Oh, I didn't package the application, sorry. No. I need to skip the test. The application was generated with the tests for the generated endpoint, and the test assert that there's hello returned from the endpoint. And it obviously isn't after my changes. So yeah, let's now build a Docker image. I have the Docker image created, and now I can just use kubectl to start. To start the my pod in Kubernetes. I used version 98. Let's see if it starts. Get pods. It's in an error state. It's always like that. So kubectl logs. Let's see what happened. It cannot talk to Postgres for some reason. It should be able to talk to Postgres. Oh, I know what's wrong. I need the configuration. Yeah, configuration now is mentions localhost everywhere. So I need to override these values for Kubernetes. Thankfully, I can do it easily with a config map. So I have a config map already created. kubectl get config map. So it's called search config. And I do it with kubectl set-env, and it will set an environment for the deployment search that I just created a couple seconds ago from the config map that I have. This is it. I wanted to catch Minikube creating the pod, but it was so fast that I couldn't. So search is running here now. So let me go to the search engine that works in Minikube. So for that, I will do Minikube service front, and I will take its URL. I have exposed front using node port. Okay, so it works. It talks to the ad service. It has the default ad. Let's search for Java. Oh, it didn't work. Why didn't it work? Oh, it didn't work because I don't have a service. Sorry. So I need to expose a service for my search deployment. So let me do kubectl x. Oh, sorry, kubectl expose deployment search. Does it? Should work now. Yep, it worked. Forwarded the query to Kafka, and the ad service was able to provide an ad based on the query. I'd like to briefly show you the other parts of the system now. So the front service comes with a web page that with Quarkus you put into meta-inf resources, and it exposes two endpoints, one for ads, that's just on path ads. It's a get method. It takes user ID in the path and just calls the ad service. The ad service uses the call to the ad service uses MicroProfile REST client. So I have a JAX-REST annotated client, interface, and that is not implemented in my application, and I just use it with REST Client Builder to build some kind of a stub that I'm able to use to talk to the ad service. It's exactly the same with the search service. What's also important here is the fallback. This is the thing that shows some data on error. So when we had this fallback and my Twitter URL shown on the front page, it was coming from here, from a fallback defined on a call to search. Okay, so this was it, and I know ad service also has one important element that I haven't showed yet. Let me also open it quickly. Okay, so ad service doesn't differ much except for consuming stuff from Kafka. Configuration is quite similar to putting stuff to Kafka, but here instead of having a stream that I annotated with, emitter that I annotated with stream, I just have a method that has an incoming annotation, and I am able to get elements from Kafka. Okay. So I think that's it if it comes to code. If you're interested in the code, as I said, there's a bit.ly link right here. I'd like to invite you to a hands-on lab today at 2:30 at Room Lab 2. If you'd like to experience Quarkus yourself with our help, with help of me, Maciej, and Mario, then please come. And it would be good if you could come with Docker, Minikube, Java, and Maven installed. It will be around this MicroProfile stuff as well. Yeah. Do you have any questions? Yep.
Any plans for Spring integration?
So for now, there is a you can use Spring annotations like AutoWired and bin scope defining annotations for instead of CI. By Spring integration, do you mean, I know, Spring MVC or whole stuff like using JMS templates, etc.?
Whole stack.
No, I don't think so. Okay. I don't think there's a need for that.
Because you showed a lot of replacements for many of, for example, Spring Cloud features, yes, but...
Yep.
Yeah, okay, thanks.
This MicroProfile is an initiative to define specifications for that, and there are a couple of companies involved. This replacement for Spring Cloud, and I don't think there will be I don't think there will be a port of Spring stuff to Quarkus for the same features.
We've got a question up here. Let's
Yep.
get this gentleman here.
Yes, in this API you provided the endpoints, the paths.
Yep.
Can you secure them using OAuth?
Not in a MicroProfile way. In a Quarkus way, I think it should be doable with Elytron, but I don't know. I've never tried it.
Okay, thanks.
One more question? Oh, there. Okay, there we go. We got a question right here.
What are the constraints if I'm not interested in the compilation to native code? For example, could I use some Spring stuff like Spring Boot if I'm not interested in the native compilation in using Substrate VM?
I'm not sure how Spring Boot could be used here, but you can use any libraries you want if you're not interested in the native compilation. The only thing I can think of that could be breaking this way would be the reload. I'm not sure if you add some libraries, it will still be working.
Okay, one more quick question. Is there a Gradle plugin? Or
yes.
Okay.
There's a Maven Gradle plugin, and there's also some Kotlin support, but I'm not sure how good it is. I've never tried it.
If you have any further questions, you can probably meet with Michał afterwards. All right.
Yep.
Thank you very much, Michał Szynkiewicz.
Thank you.